On June 12, 2025, Air India Flight 171 lifted off from Ahmedabad. 34 seconds later, the aircraft hit the ground, tearing into a medical college hostel. The impact and resulting fire killed over 270 people, including students in the hostel canteen and nearly everyone on board. Search teams recovered only one survivor from the wreckage. The aircraft involved was a Boeing 787 Dreamliner. For over a decade, the aviation industry has marketed this specific model as a masterpiece of modern safety and redundant engineering. Heavy commercial jets do not simply fall out of the sky. They are designed to stay airborne even when major components fail, making a catastrophic drop shortly after takeoff an extreme statistical anomaly. While formal investigations may take years, a clear sequence of events is already visible in amateur cell phone footage, recorded air traffic control audio, and the physical state of the wreckage. The evidence recorded in those 34 seconds reveals a highly complex mechanical system actively shutting down in midair. A 17-year-old witness on the ground captured the plane's final moments on video. His footage shows the Dreamliner struggling to maintain its climb, reaching only 625 feet. In that video, the landing gear is fully extended. Usually, pilots retract the wheels the moment the aircraft clears the runway to reduce aerodynamic drag and allow the plane to accelerate. The wing flaps are also visible, and they are completely retracted. For a heavy, fuel-loaded plane to lift off, these flaps must be extended to provide the necessary surface area for low-speed lift. This configuration suggests the crew failed to prepare the aircraft for flight. But a simple pilot error is difficult to reconcile with the 787's design. The Dreamliner uses an automated warning system that triggers loud, persistent alarms if a pilot attempts a takeoff with incorrect flap settings. Given the captain's 8,200 hours of flight experience, the more likely scenario is a total mechanical refusal to respond. The pilots likely moved the controls, but the aircraft lacked the internal power to move the heavy hydraulic components into place. A small object is visible protruding from the belly of the aircraft in the witness footage, accompanied by a high-pitched propeller buzz that stands out against the engine noise. This is a ram air turbine, or RAT. It is an emergency wind generator that deploys automatically to provide a small amount of electricity to the cockpit when all other power sources fail. The RAT is a final line of defense. It only drops when a plane suffers a total loss of electrical or hydraulic pressure from the main engines and the backup generators. This visual matches the final radio call from the pilots to air traffic control, where they reported, "Thrust not achieved." The deployment of the emergency turbine, combined with the pilot's report of zero thrust, confirms a dual-engine failure. This 200-ton machine was gliding without power. Jet engines are engineered to be entirely independent. For both to stop working just minutes after refueling, investigators look for a common factor that affected both systems simultaneously. One theory involves fuel contamination. If water or sediment from the airport storage tanks entered the wings, it could have clogged the fuel lines and choked the combustion in both engines at once. Another possibility is a total electrical failure. If the generators that start the engines fried during takeoff, the electronic controls could have shut down before the backup power units had the 90 seconds required to start up. A third theory points toward a manufacturing defect in the engine controls, a pre-existing flaw that failed under the high-pressure environment of a maximum weight climb. Regardless of the specific trigger, investigators are searching for a technical failure that likely began before the plane ever left the ground. To find the root of that failure, the investigation moves back 11 years to January 2014, the month Boeing delivered this specific aircraft to Air India. Internal Boeing records from that period show that employees had already flagged serious concerns regarding shoddy manufacturing and metal debris left inside the airframes during assembly. Whistleblowers like engineer Sam Salepur testified that management pressured workers to ignore these safety violations. The priority was maintaining the speed of the production line over the precision of the build. Former quality control managers at the factory reported finding tools and trash near critical wiring, telling their own families they would not fly on the planes built on that floor. Air India's own maintenance records add to the timeline of neglect. Passengers on Flight 171 reported that the cabin air conditioning and entertainment screens were non-functional just hours before the crash. Regulators have previously documented instances of the airline faking safety audit reports, while pilots have repeatedly warned that chronic crew fatigue was compromising operational safety. This illustrates the Swiss cheese model of aviation disasters. A crash happens when multiple layers of protection fail at once. When manufacturing defects, poor maintenance, and mechanical failures line up, the red line passes through. The loss of AI-171 was the final result of failures that began on the factory floor and continued through years of neglected maintenance, ending when the corporate cultures tasked with